Okay. So, whoops, 3-1 and 3-2 today. So 3-1 you should be familiar with, at least on some level, I hope. Our measures of center, so where's the center of our data set? This is going to be our mean, our median, and our mode. Oh, that looks bad. So most people have dealt with the mean. When you think of the average, that's what mean is. The median is your middle, mode is your most common. I'll do some more and more examples of those. So we always have two symbols for things. Simple. So your population mean, we use the mu. It's another Greek letter. We really like Greek letters in math. So it looks like a mixture between an M and a U is kind of how I always thought about it. So that's our population. We use that in some of our statistics, but usually it's going to be 0 for us. Our sample mean is really what we calculate. That is the X bar. So X with a bar on top. I'm not even going to give a formula for the other one. It's really the same formula. Okay. Your formula for the mean, I'm going to make it look fancy because again, we need to get used to this notation. It's going to stick with us. It really means just to add up all of the number, or add up all of our data values and divide by the number of data values. So as you were taught in whatever grade we learned mean, it's the same thing. Add them up, divide by the number of numbers. Pretty straightforward. So we'll do one little example of this. Let's say my data set, here's my X's. I get 62, 88, 77, and 68. I did bring my calculator today. Yeah. All right, so our N is 4 because we have 4 data values there. Right, add them all up. Oof. 62 plus 88 plus 77 plus 68 gives me 295 over 4. And I get 73.75. Rounding is always tricky in any class, really. Homework's going to tell you exactly where they want you to round to. My rule of thumb with statistics has always been 1 more than the original data set. So our original data had all whole numbers. So I'm going to go out 1 decimal, 73.8. And that's our mean. I'm going to go shut this door because okay. Is anyone not familiar with mean? Are we good to just say, hey, there it is, bye? The other two are more interesting. Whoops. All right. Our median is more fun. Our median is our exact middle value. So we're going to take our data set, arrange them from smallest to largest, and figure out what our center is. If we have an odd number of data values, this is really easy. If we have an even number, we have to do one extra step, which isn't a hard step. We just have to remember to do it. So let's do one of each. my data set. I just grabbed these numbers. I don't know what they mean. Doesn't really matter for us. 179, 257, 201, 206, 240, 222, 217, and 208. So the most important thing to remember about, one of two most important things to remember about the median is we have to rearrange the numbers. If not, you could have the same data set, and depending on how they're arranged, you come up with two different medians, which doesn't really make sense. Our goal is to everybody gets the same numbers. So we put them from smallest to largest. I like to go vertical for that. 179, 201, 206, 208. 217, 22, 240, 257, and 284. Our N is 9, so half of 9 is 4.5. So that tells me I'm going to look for the fifth data value. 1, 2, 3, 5. Count the other direction. 1, 2, 3, 4, 5. They agree. Yay. So our median is 217. No, I want that. No, I don't need notifications. Thank you. Okay. A new data set. This time, I believe we have 8 data values, or maybe 10. I don't remember. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 10 of them. Okay. Again, rearrange them. 62 is my smallest. 68. 71, 74. 77. 82, 84. 88. 90. And 94. Yep. Okay. So our N is 10 and half of that is 5. So if I count from the bottom and the top, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, we get different numbers. So you always want to count from bottom and top. When this happens, when we have an even number, you take your middle 2 and find the mean. So we're going to say 77 plus 82 over 2, which should be 79.5, according to what I wrote down before. Why don't you want to write there? Hang on. Okay, so officially, if your n is even, you take your data value in position n over 2 and the next one n over 2 plus 1 and find the mean of those two. So this is our position n over 2, n over 2 plus 1. Or count from the bottom and the top. Do your thing. Okay. Our last measure is our mode. That is our most common data value. So far, our data sets haven't had a mode because they've all appeared exactly once. But let's say we have 1, 2, 2, 3, 4. The number that appears the most there is 2. Sometimes your data sets will have no mode. Sometimes they'll have a couple modes. Excuse me. So if we have 2 modes, we'll say it's bimodal. We could be trimodal. Usually after that, you just say there's no mode because that gets a little silly. So bimodal, there's 2 of them. Okay. A good study is going to show you the mean, median, and mode of their data. If not, you don't know what measure of average they're talking about, and mean, median, and mode all tell you slightly different things. They all measure the center, but in different ways. So we have something, ideally, I'm really bad at drawing these somehow. Our data set looks like, our bar graph will look like a bell curve, and we want our mean, median, and mode all to be at exactly the center, ideally exactly the same data value. It doesn't usually work that way, so they should just be close to one another. That's the best. A lot of times we'll have something called an outlier, which is a number that's way bigger or way smaller than everyone else. So our outliers, wow, that looks bad. In this case, we have a really high data value that's pulling things away, and it's going to pull our mean farther to the right. So your mean is really sensitive. If you have a really high or really low data value, it's going to move the mean a lot. So if you have a really weird data set, the mean is probably not the best way to convey the center. But also telling you all 3 will say, hey, you've got some outliers that's pulling your mean away. It tells you stuff about your data. If you want a bimodal data, kind of looks like a camel. So your modes will both be there where your mean and median will stay in the center. This is why you want to give as much information as possible or that it's meaningful. So that's what that looks like. Be careful. Like you'll see this a lot of times in like brochures for something. They'll say something about our data, like the average age of our students is 25. Maybe that's true, but maybe they're also, most of your students are 18 to 22, but then you've got a couple like 80-year-olds in there pulling the mean away. So If they don't tell you which measure they're giving you, they're going to give you the one that tells their story the best. So always be suspicious. Honestly, that's the theme of this class, always be suspicious. Ask why they're giving us these data values and what else could they be telling us that they're not. So be careful. All right, 3-2 is where we're going to spend pretty much the rest of our time. Dispersion is a tough word for me to spell. Measures of dispersion. How is our data values, are they really close together or are they really far spread out? Because you can have two data sets with the same mean, but if you look at the data values, they look a lot different than one another. So having a way to measure how tight or how spread out our data values is helpful. Our first measurement is our range. This is probably the simplest measure we will do in this entire class. And it is our maximum data value minus our minimum. That's it. You take the biggest one minus the smallest one. That's our range. That's how wide our data set is. I have confidence we can all calculate that, so I'm not going to worry about that one. Where we're going to spend the rest of the time is not so easy. Standard deviation. Distance of each data value from the. Okay, so our standard deviation is it measures the deviation. So the average distance of each data value from the mean. And I put average in quotes because it's the mean distance, but I didn't want to write the word mean up there twice. So average gets to be in quotes. So how do we measure that? That's the fun part. Our sigma is our population. Standard deviation. You'll notice that our population things are typically Greek letters. Our sample are going to be regular US letters. So S for standard deviation, we use a little s for our sample standard deviation. I have 3 formulas to throw at you. We're going to practice 2 of them and but we're really in theory going forward, we're only going to use 1 of these, but they're all helpful. So our first one is the conceptual formula. That's an E. Sigma x I minus mu squared all over n. So our conceptual formula, our sigma, is the square root of the sum of each data value minus the mean squared all over n, big N for population. So we're going to use that in a sec. A nicer version of this equation, even though it doesn't look nicer, it's easier to calculate, is going to be sigma equals, this is hard to write, sum of x sub I squared minus sum of x sub I quantity squared all over n all over big N. We're actually not going to calculate that one, but our next one is very similar to that. And it's for our S. Sum of x sub I squared minus sum of x sub I quantity squared over little n all over n minus 1, and we take the square root of it. After the first example where I do the first equation, you're going to use the highlighted blue, the S formula going forward. It's the sample one. We always do sample things. The caveat to that is homework tells you to use one of the other ones, do that. But typically we're going to use this highlighted one. Okay. I am going to bring you with me because I want you. Oh, never mind. We'll just rewrite it. Okay. Mean, we did this before. 73.8. I don't want to put that right there. I'm going to put that underneath. My N is 4. And the formula we're using is sigma equals the sum x sub I minus mu squared all over n. So a formula like this, I think of it as a process rather than just a straight formula, because as it stands, we can't plug anything in there yet. Well, we can plug the n, but everything else we have to do some extra stuff to it. So the first thing I want to do is subtract my mean. I'm going to make a couple more columns here. Okay. So 62 minus 73.8 gives me negative 11.8. We square that. 139.24. Okay. 88 minus 73.8. 14.2 squared. 201.64. 77 minus 73.8. So far, I've subtracted my mean from each of my data values and I squared them. It's easier to do that as one like back-to-back calculator thing, which is why I did both columns at the same time. Now, if we were just to take the average of the distance from the mean, if you add up that middle column, you're just going to get a 0. because half our numbers are negative, half are positive, add them up, we'd have a zero difference. That doesn't tell us anything, at least nothing helpful. So that's why we have to take our data values and square them to make them all positive. And now we can play with this a little more. So we almost have what we need. I'm going to take this last column here and add it up. Plus 2, 1, 6, 4, plus 10, 24, plus 33, 64. So that summation is that crazy sigma minus x sub I minus mu squared. We just found that. We subtracted the mean, squared the data values, added them up. So now we can plug into our formula. Our sigma equals 384.76 all over 4. Divide it by 4. 96.19, which equals second square root, second answer, 9.8. So what this tells me is my data values are kind of spread out. So there's on average, they differ from the mean about 9.8 digits or data values or whatever, digits. So you have to look at our data set to decide if that's a big standard deviation or smaller. Most of the time, we're going to compare them to two different, like compare data set A and B, their standard deviations to see which one's more spread out versus the other. We will do that at the end. I have a good example for that. Let me get that. And then we'll do my example. Okay. We're going to come back and use this highlighted formula, but I want to kind of throw out my other things first, and then we'll look at these, another example. So we'll come back to that. This one is pretty simple too to calculate. Our variance, variance is weird. I know what we use it for when we're looking at our correlations, but for standard deviation, I never quite, whatever, it's variance. It's S squared or sigma squared. I've never found we used it for much yet, so that's our variance. We have an empirical rule. We will spend more time with this in a different section. $68, $95, whoops, 99.7. So our empirical rule is also called the 68, 95, 99.7 rule. What this says is we create our bell curve. Let's see how lovely I can draw this. 2.5, 2.5, 2.5. Okay, can I match it on the other side? Usually not. You know what? That's not bad, I'll take it. Okay. So here is our standard bell curve. Our mu is in the center. If we were to, I'm trying to find what color, this one's fine. We could say, okay, one standard deviation above the mean is going to occur right about here. One standard deviation below the mean is here, and we have a bunch of data values in between. 2 standard deviations and 3 does the same sort of thing. We will dive into this more, but I'm gonna loosely explain it now. And then I think 3, 4 is where we hit this pretty hard. The empirical rule says 68% of the population falls within 1 standard deviation of the So 68% of our cases should be within 1 standard deviation of the mean. So that tells me most things or most people or whatever are close to the mean. They're pretty average. So most of our sets will be close. Then we're going to find that within 2 standard deviations of the mean, we get 95%. And finally, within 3 standard deviations of the mean, almost everybody, we get 99.7%. 99.7% are within 3 standard deviations of the mean. You're always going to have a few outliers in this case, or data values that are really high, really low, but they're rare. I want to say 0.15% of them fall on those tails. So most of your stuff is near the center and fewer things near the outside. Yeah, we'll dive into this more later, but we should introduce it now. The last thing before we get into our big examples here, can I scroll past? I'm sorry, did I? Is a really fun one to say. Chebyshev's inequality. I hope I said that right. I think I did. So for any data set, at least 100 times 1 minus 1 over k squared % of cases lie within k standard deviations of the mean, as long as our k is greater than 1. Okay, so let's say we have a data set with a mean of 100 and a standard deviation of 16.1. We want to figure out for a k of 3, so what % falls within 3 standard deviations of the mean? Take 1 minus 1 over 3 squared. 1 minus 1/9. And that gives me 0.889 or 88.9% are within 3 standard deviations of the mean. If we want to put that a little bit more concretely, we can make an interval. So we take our mean plus or minus K times our S. So really this turns into 2 separate equations. So the first one, we take our mean minus our K, which was 3, times our S. And then our high value, we do that plus adding. So 3 times 16.1. This gives me 51.7 and 148.3. So we could say 88.9% of our data values are between 51.7 and 148.3. So how spread out is our data? Excuse me. Okay. I have 2 examples slash sort of 3 we're going to look at. So the first one is slide 61. Since there was only one slide, I didn't print it off. Here's our data values. We're going to do standard deviation with these guys. So let me scribble these down. 82, 77, 90, 71, 62, 68, 74, 84, 94, and 88. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my little n equals 10, and our formula, let's grab that again. S equals so we're going to use that regular standard deviation formula, which works a little different than the other one we did. So we know our n value, I counted them, we have 10. We're going to make another column for our data. And then we're going to add up these 2 columns. All right, the first one, I'm just going to add my column of numbers. So 82 plus 77, 90, 62. Did I get all of those right? I really hope so. 7, 90. We don't actually have to find the mean, which saves us a little effort. Okay, so when we calculate that first column, that's the sum of our x sub i's. Now, the tedious part is we have to go through and square each of these data values. If you have a spreadsheet, a lot of times you can just input your data and use a formula to tell it what to do after that. I'm going to do it by hand because that's what we're here for. So I'm going to square each of these. Meet me at the end. All of them. Now we get to add that. So let's see. Plus 100. Get 6, 3, 3, 7. Okay. I have all of the pieces I need to solve this. The tricky part is now knowing which one to plug in first. So our formula, I get S equals, this one says square all of our x values. Sorry, you can't see where I'm pointing. This one says square your x values first and then add them up. So that's the second thing I got. So that is my 63,374 minus, now the second one says add up all your x values and then square it. So 790 squared over 10. Okay, 63374 minus 62,410 all over 9. So go through, do all the steps. I get 10.3. Okay. We're going to do this again, but we're going to compare two data sets and you're going to do it instead of just watching me do it. So I'm going to give you the data sets, and then if you want, I can show you how to do this in Excel or Google Sheets. Some of it, like, can't do all of it. Okay, So let's say we have two data sets, X and Y. Our first one gives me 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That I asked ChatGPT to give me some data sets, and that's one of the ones they gave me. Gotta love AI. All right, our second one is 1, 3, 5, 8, 10, 12, 14, 18, 20, and 23. And we're going to find our mean of this one is 10, and our mean of our other one is also 10. So two data sets, their mean is the same, but if we look at them, we can tell they're not similar. Our first one, the range is 9, so there's a 9 difference between the biggest and smallest. The second one, our range is 22. That's a big difference, but range doesn't really tell us all of the story. So what we have to do is find the standard deviation of each one. So we don't really need the mean, but we have it. I probably should have spread these out a little more. So go through and find your x squared and y squared columns. And this is where I'll show you how to do it otherwise. Does everybody have the data set down if you want it down? Okay, so I have Excel on this bad boy. You know what? Okay. So if we want to do this the fast way, we can make two data or two things here. Gonna work. There we go. 5. Leave some space. Okay, get your two data sets in there. Gonna set equals sum, parentheses, highlight what I want it to equal or I want it to add up. Same thing, equals sum. I like my boxes. Okay. And here's going to be my x squared. So equals previous thing times itself. And autofill, yes. Equals previous thing times itself. And yes to autofill. So now we have gotten all of our data values very quickly and we didn't have to work real hard for them. So my sum of x, I'm going to write these down for myself. 95. The sum of x squared, 90, 25. Sum of y. Sum of y squared equals 1299, 6. I'm going to write those down and then pause this while everybody does their thing. Give me 1 second, I will be happy to answer. Okay, yes. We're multiplying first and then we're adding. Yep, so you're gonna take like 5 times 5, 6 times 6, find all of those, and then add that new column. I can never remember this one. 96. Some of that should be 90, 25. It seems really big. Google Sheets, did you lie to me? Yes. Okay, sorry, Google Sheets did a thing. They took my 95 and squared it. That's better. Okay, that makes way more sense. Always check your data. I looked at that. I looked at all my numbers. I'm like, none of those numbers is more than 200. Why am I adding to something with 4 digits? Like 9,000. So I knew something was off. And that made me say enough, like, let's go check our data and see what happened. So it squared the numbers instead of just summing them up like we did last time. So my numbers are a little off, but that is okay. Nope, that's where I need it to be. One more time. Thank you. $985 and 1792. That is more like it. Okay, I'm going to pause my video and I'm going to have all of you throw this into the formula we just used. Okay. I'm going to throw the X's in here. If we have time, we'll do Y's as well. If not, it's the same process. It's just, different numbers. So that's 10 and 10. Let me throw this in pink. The sum of X squared, this is our 985. Minus, now we take the sum of our X values, so 95 squared over our 10, all over 10 minus 1, whole thing squared. All right, I'm going to do that parentheses first. So 95 squared. Hey, there's that number that Google told us was the thing when it wasn't. Okay. Divide by 10. Whoops. I get square root 985 minus 902.5 over 9. I'm going to do this one together. So 985 minus our 902.5, the whole thing divided by 9 gives me roughly square root of 9.16 repeating, which their standard deviation is going to be a little different than mine, isn't it? Yeah, okay. So ChatGPT gave me the wrong standard deviation, but it was pretty close. They may have used a slightly different formula from us. It's in the ballpark. That's what really counts. And then for the Ys, we would do the same process at putting in this, the appropriate numbers that are slightly different, but the same sort of thing. The biggest thing is your order of operations and knowing when to plug in the squares versus the regulars. So I tried to show that. Can I highlight here? This is my regular. This is my regular. Here's my squares. Here's my squares. I know I like color coding things if I can. Oops, there you go. So that's where our different numbers all come from. Hopefully that helps a little bit. I like colors, so I like to do colors if I can. Yeah.
So is the 95, is that, these X's all added up?
Yep.
Okay.
I highly recommend a spreadsheet. I mean, everybody can get to Google Sheets for free nowadays. Most computers have Excel, not all of them, but many of them. There's spreadsheet functions. Use that to do your squaring and summing. So square them all first and then sum them up as we learned today. But that'll save you a lot of time and effort, and you'll be able to do that on the tests and things too. I don't expect everyone to do all of that by hand. Knowing how the formula works, sure, but not the summations. That's just tedious. We can all hit those buttons. So, okay, that hit us really good on time. So I'm gonna shut this down. If you have questions or issues, let me know. I know we're still having issues getting into the homework. I'm trying to fix it. It's pulling from old links. And so it's a matter of making the match up again. All right, bye everyone out there in TV land.